Here we're going to look at some edge detection capabilities in the pixel processing software. Before we actually look at some edge detection filters, we'll first examine an edge to see if it's any good. And we have another tool that will help us do that. I'm going to open this part here as a grayscale or monochrome image, and we're going to select the line profile tool, and we're going to change the shape tool type to line, and then select a line somewhere in the image. And here I've intentionally selected the line so that it crosses a couple of edges. When we look at the line profile, what we see is actually a plot of grayscale values along this line. So the line begins in this dark region in this hole, and we have darker values here, and then there's a transition to a brighter region, and that's this increasing or positive transition from dark to light. And then we have a segment here that's in the brighter region, and then a transition to a darker region. And this is what you want to look for when you want to find edges. It's useful to have strong transitions from light to dark or dark to light. So let's look at a few of our edge detection features or capabilities. The first one is called the Canny feature, Canny filter. And there are different parameters you can look up in the documentation. If we apply this, you see we get really nice edges around the transition areas. So Canny filters can be very useful in finding edges. Another one is a Laplacian, and I'll put it here in this second image window for comparison. And if we apply that, it also picks up edges, but it also picks up noise in the background, maybe due to the pattern on the part or an inconsistent background, and maybe even due to lossy compression artifacts from a JPEG image. So the Laplacian is okay, but maybe not quite as useful as the Canny filter. It's sometimes common before applying a Laplacian filter to do some blurring of the image, but we'll look at that in another demonstration. The last one we'll look at is the Sobel feature, and the Sobel really takes derivatives or changes in either the x direction, the y direction, or both. So for example, if we look at the Sobel filter in just the x direction, what we can see is that we get really strong response on vertical areas of the image. In other words, the brightest areas are those that have the most change going across. So the top and bottom edge of the part, and then the top and bottoms of the circle don't show the best transitions, or don't show any transition or any edges. We can change that and get just the top or the bottom, and you see we have just the opposite. We're looking at changes in the vertical direction or the y direction. If we wanted to get them both, one thing that you may do is to get the horizontal transitions in one image and the vertical transitions in another image, and then combine them with an arithmetic operation. In this case, the arithmetic OR might be useful here. So we're doing a logical OR operation on these pixel values, and now we get pretty good response on all the edges. One other interesting feature of the Sobel operation is that you can choose a polarity, and that is you can choose a change in pixel intensity of any, which is the default, or positive or negative. So let's take a look at that. If we look at a positive change in the x direction, what you can see is that we only get a response when we go from a dark to a light area. And here within the holes we're going again from a dark to a light area. When we go from a lighter area to a dark area, we're not getting any response because that's a negative polarity and we didn't ask for that. So it may not be obvious here how useful this can be, but in other demonstrations when we're looking for circles and ellipses, it turns out that this polarity capability is actually quite useful. For more computer vision demos or to try out the software yourself, visit pixelprocessing.com and feel free to leave some comments on this video or feel free to contact me. Thank you for watching.